Okay, here's the second half of 5.9, talking about complex numbers. Now, complex numbers are when you mix a real number and an imaginary number. So, for example, a here is the real number, and b times I is some imaginary number. So here's 7 plus 4i, or 2 minus 6i. Those are complex numbers. And what if they gave you an equation, complex numbers, and look, we have x's and y's. How do we solve something like this? Well, there's a real part, and there's an imaginary part. So you're going to actually separate those two. So I'm going to do the real on the left. That's going to be 2x minus 3 equals 3. And the imaginary is y minus 4i equals 2i. That's the imaginary part. So I'm just going to solve these separately. Add 3, and I get 2x equals 6. Divide both sides by 2, and I get x equals 3. And then over here I'm going to divide both sides by I, and I get y minus 4 equals 2. Add 4 to both sides, and you get y equals 6. And there's how you solve it. You're just going to separate the two parts and make two equations. That's all there is to it. So I want you guys to go ahead and try that on your own real quick. I'll put the answers up in just a second. So here you go. You may want to pause the video now. Okay, if you separated the real part and the imaginary part, you got these two equations, and you solved and you should have got x equals 2 and y equals 5. There you go. Okay, what about this? What if we're adding imaginary numbers? Well, this one, since we're just adding here, we could really ignore these parentheses and just combine like terms. So here's our real part, here's our imaginary part, and now we just add. 6 plus 1 is 7, negative 4i plus 3i is negative I. That's it. That is it. Okay, how about this one? Well, the only trick here is you got to distribute that negative. So this is actually a negative 5 and a positive 4i. And this is the same. And we're going to do the same thing. We got a real part, we got an imaginary part. 3 minus 5 is negative 2, and negative 2i plus 4i is positive 2i. That is it. Okay, let's say we wanted to graph this. Well, here's the deal with graphing. This is your imaginary, the y-axis, your imaginary axis, and this is your real axis. All this is just a location. So this is 7 over, or positive 7 in the real, and down 1 in the imaginary, and that's it. So it should be right there. Is that 7 over? Yeah, 7 over. So that is 7 minus I graphed. That's how you graph imaginary or complex numbers. So why don't you guys try to graph this guy. Remember that this is the imaginary and this is the real. Go ahead and see if you can graph it. You may want to pause the video because I'm going to put the answer up in just a second. Okay, well, hopefully you went back 2 in the real and up 2 in the imaginary, so you should have graphed this right here, negative 2 plus 2i. By the way, I'm graphing these things above in case you didn't notice. Okay, a couple little things here. This is primarily what imaginary numbers are used for. It's in circuitry. So in an AC circuit, the voltage E, current I, and impedance Z are related to this formula. E equals I times Z. Find the voltage in a circuit with the current 1 plus 3i amps and impedance 7 minus 5i ohms. Okay, well, let's think about what this means. This means that E equals, well, what's my I? Well, they said that my I is my current, and my current is 1 plus 3i amps. And then they said that my Z is my impedance, and my impedance is 7 minus 5i ohms. Well, I'm multiplying these two things together. It's kind of like a binomial. So I'm going to do the same thing I did for those. I'm going to make a box. And let's multiply in this box. 7 times 1 is 7. 7 times 3 is 21i. Negative 5i times 1 is just negative 5i. And here's the tricky part. Negative 5 times negative 3, well, that's negative 15. And then I times I, that's I squared. Well, remember that I squared is just negative 1, so this is really like negative 15 times negative 1, which is positive 15. So now we're just going to combine our like terms. And we're going to get that E equals 7 plus 15 is 22. And 21i minus 5i is 16i. And there is my voltage. So you can say 22 plus 69 volts. Okay, what about when it comes to rationalizing these imaginary numbers? Well, since I is technically the square root of -1, we cannot have it on the bottom. So we can use, since this is a complex number, and very similar to radicals that are being added to a real number, or a whole number I should say, we can just use the conjugate. So I'm going to do times this by 2 minus 4i over 2 minus 4i. We just multiply by the conjugate over the conjugate, and this is going to clean it up for us. 3i times 2 is 6i. 3i times -4 is going to be -12 times I squared, which we know is just -1. I'll simplify that in a second. The conjugate rule says, and it's the same rule here, that we square the first term, and it gets us 4 minus the square of the second term. If we square 4i, we get 16, and I squared is -1, so -1 times 16 is -16. Okay, a couple things here. -12 times -1 is positive 12 plus 6i over 4 minus a negative is the same thing as saying plus. So 4 plus 16 is 20. And technically we could split this off. We could reduce and split this off. So instead of 12 over 20, I could write that as 3/5 plus, instead of 6i over 20, I could write that as 3i over 10. And that's the best answer, because now it's written as a complex number. There's my A, there's my B, and there's my I. Okay, let's try this one then. So a lot of times people here are going to want to multiply by a 2i, but you don't really need to do that. If you think about it, all you need for this I to become rational is another I. So we're just going to multiply this by I over I. So 5 times I is 5i, plus I squared is just -1, over 2n times I squared, which is -1. Let's simplify this a little bit. This is like saying -1 plus 5i over -2. And we can break it down to be -1 over -2 makes positive 1/2. Oh, and then we would have -5/2 I. Again, there's my A, there's my B, there's my I, and it's in the proper complex form. Alright, I'm going to let you guys try this one. This is the trickiest one. You are going to have to use the box or foil on the top after you multiply by the conjugate, so give it a shot, and then I recommend pausing the video. I'll have the answer up there in just a second. Alright, so first of all, you should have multiplied by the conjugate, top and bottom, 3 plus 2i. On the top, you would have had to use the box or foil, so here's the box method. I got 6 and -2, which makes 4. I got 3i and 4i, which makes 7i. On the bottom, when you multiply by the conjugate, you square the first term, you get 9, minus, square the second term, you actually get -4. 9 minus a -4 is positive 13, so when you break this down, you get 4/13 plus 7/13 I, and there's your answer. Alright, that's it for complex numbers. Hopefully that helps. I'll see you guys on the next video.